I have a problem here. I have this data, and I'm asked to create a scatter plot and then to create a linear model for this. So we have the year and the world record time. And one nice way to make a graph of this instead of on paper, which paper's good, but spreadsheets are great. So I'm going to highlight from the word year over and down to the end of the last number, no more, no less. And I'm going to copy it, come over to my spreadsheet, and paste it in. And if I copied it right, it should paste and look pretty much the same way. Okay, that looks pretty good. And then for a graph, I can insert a chart or use the Insert Chart button here. And sometimes Google guesses what I want. No, I didn't want a line, I just wanted points. So let's see. Over here, yes, a scatter chart, that's what I want. And then I have all this empty space here, so let's fix that. Customize, vertical, and then I think we just need to change where we start. So let's see, what's the earliest time there? The shortest time is 9.6, so we could start at 9 for sure instead of 0 vertically, right? We got all this wasted vertical space. So let's set them into 9 and see what it looks like. Okay, that's a little better. Could even go 9.5 would be fine, but that's okay. All right, next, when I just can't see me doing this here, but I'm holding a line up to a piece of paper on my screen here. I'm trying to put the piece of paper so like half the points are above and half the points are below. And I'm thinking like the second point. All right, so I'm thinking this point here looks good. So I'm going to change its color. Ooh, I don't want to change all of them. Well, that's not what I wanted. Let's try that again. Oh man, it undid the vertical. That's okay. Let's do it again. Vertical. I think you can change the color of individual points. Minimum. Am I in the right spot? 9. Yeah, there we go. All right, and then let's see. I was thinking that point looked good. Maybe I got to click one more time. Ah, there we go. I had to click a third time. And let's make it red. And I was thinking this point right here. So let's make that one red. Which two are those here? Second one, so this one here would be good points for a line. And what's that one? 1, 2, 3 in between. 1, 2, 3 in between, so that should be that one right there. And so those are my 2 points right there. So let me put my paper up to the screen again. You could try this at home too. Oh no, I don't like that now. I'm thinking the one before it. Okay, so let's undo. I think I like this one better. Yellow. All right, so not that point there. So I click once, twice to get the point, and a third time. Oh, it's not bringing it up. I guess I have to edit. There we go. Click, click. There we go. Customize a point here. So not that one. What was it before? One of these blues here. I want that one. Am I on that one? Find out. Okay, yeah. So there's a bit of trial and error here, but bottom line is if you want to find a line, you need 2 points. Okay, I like those 2 points better. All right, so I need to find the slope. So, and I couldn't pick 2 points until I did that because let's say I pick these 2 points right here, then my line's going to go like almost straight up and down, and it doesn't go through the rest of the points. So you can't just randomly pick 2 points. You got to think about it, graph them in a computer or paper to decide which points to use to estimate a line through the points. So those are my 2 points there. Let's see, maybe I'll come down here. So I need to find the rise. Remember, the rise is the change in the y values. So these here are my y values, and I just want to subtract them. So I'll take this y value minus that y value. Okay, and that makes sense. From this point to that point, I'm dropping down, so that's a negative. And then the run, that's that horizontal distance, right? So I just did my rise. My rise says drop negative 0.3. Now I've got to calculate the run, horizontal distance over there, equals, so that would be this year minus that year. Okay, so there's my rise and my run. And slope happens when I divide those two. So slope equals the rise divided by the run. So my slope is negative 0.008. Interesting. Let's clean up some decimals there. Oops, wrong button. I gotta click there and then decrease decimals. That's just too many decimals there. Maybe we'll just go to 3 decimal places. So negative 0.009 is the slope there. Okay. All right, let's see. I'm also let's see, for a line, I'm trying to find a linear model. So let's make a little note here. Linear model. A linear model is y equals mx plus b. And I think I got m here, right? The slope is m. Now I need b. Now b is a little bit harder to find. B goes with year 0. So year 0, that was 2,000 years ago. That's a problem. What's the problem say here? Let's read it. Okay, so table below shows the world record for men's 100-meter dash from 1912 to 2009. Use this to answer the next few questions. Oh, there's a change in electronic timing in the 1970s. There's a gap we got there, okay. And then create a scatter plot on paper. Yeah, we got a scatter plot. Let the horizontal axis be years t, where t is the number of years after 1990. Oh, okay. So we gotta fix that. All right, so I'm gonna put a new column in between here for t. T isn't the year, it's years after 1900, not 1990, sorry. So let's insert column to the left there and call it t, years after 1900. All right, so to do that, it's just, this would be 12 years later and 21 years later, so we just subtract. So equals this minus 1900 tells me how many years later, right? Subtract. How many years later? And Google says, I'll fill down for you. Sure, thank you, Google. All right. And it tried to graph those. That's a problem. We'll fix that in a sec. Not a big deal because we already saw the picture. All that matters is we have our 2 points, and we want that right there as our value of t, and this is our other value for t. And remember, t is our x-axis here. The year is supposed to be the horizontal variable. And bottom line, that doesn't really change anything. From 21 to 56 is still 35. So, but it does change the y-intercept. So I need to backtrack to year 0. And the simplest way to do that is to plug back into this formula here with information we know. So for example, what do I know? Well, I know that, for example, with this point right here, this is my y, 10.1, and the 56 is my x. And I also know m here. I just don't know b. So I'm going to use this as a piece of paper for a moment. So if I take negative 10.1, my y value, that's supposed to be equal to the slope. And let's put some spaces in here to make it prettier. Negative 0.009, right? That's my slope down here, times the x value. So if I say the y value, oh, I put a negative up there, it's positive. The x value would be 56. So times 56 and then plus b, and I accidentally put a negative in front. All right, so y is 10.1. The slope m is negative 0.009 from here, and the x value that goes with 10.1 is 56. So notice when I plug a point and the slope into this equation, I can now solve for b. So my next line here, well, this is a negative, it's being added, so I need to add it to the other side. So that means I want 10.1 plus 0.009 times 56, and that will be the answer for b. Okay, so I have a negative number on this side, I add it to the other side, and that will equal b. Now if I want to get the answer on a spreadsheet, I have to type equals first to use it as a calculator. So let's see, equals 10.1 plus 0.009 times 56, and I get my value for b here. So let's just put a b next to it there. B should be about 10.604 if I typed that correctly. So did I type it correctly? All right, so here's y equals mx plus b. Y is 10.1. Yep. When x is 56. And notice I have my 56 here. So that's my x, and then times m, which is the negative 0.009. Yeah, that looks good. All right, so now I think my equation here is y equals negative 0.009 times x plus 10.604 if I go with 3 decimal places. All right, let's look back at the problem here. What do they tell me here? R is the vertical axis. So instead of y, so usually I call the vertical axis y, they say let it be r, and let the horizontal axis be t. So instead of x, we'll use a t. Okay, so let's write that again. So instead of y equals, they want us to write r equals negative 0.009 t instead of an x plus 10.604. And I could have done all of this on paper. I just wanted to demo a spreadsheet, and I'll fix this spreadsheet, this graph in a sec. All right, so there's my equation. Let's delete the graph and fix it. And again, the reason the graph went wrong is first I made it with this column here and that column there, but then after I made the graph, I snuck in this middle column, and Google got a little confused about what I wanted to do with that and just guessed. So I want to graph these two together. So I'm just going to re-highlight them, and then click Insert Graph. And it picked a line chart. I want a scatter plot, which means plot the points. And then let's get rid of that empty space. Right, we got nothing going on until around 9 seconds up here, 9.5 seconds. So customize vertical. It takes a little bit to get used to all these options they offer. Let's vertical be 9 instead. Yeah, that's a little better. And then again, we are using this point right here and that point right there. Okay, so we're making progress. We have an equation there. Rise, that's the change in the two y values here. Run, that's the change in these x values. And it doesn't matter whether I take 1956 minus 1921 or 56 minus 21, I'm still going to get an answer of 35. And slope, remember, is always rise over run. So we take that rise, divide it by the run, and then I round it to the thousandth here, nearest thousandth. Then we have to go back, plug in one of the points and the slope to get the y-intercept. Now, because of rounding, If you had plugged in this point instead, you'll get a slightly different y-intercept, but it would have been close. They're both going to be about 10.6. But rounding will make answers slightly different in the long run. All right, hope this was helpful. Take care. Do good math.